Okay guys, so to start for today, kind of reteaching from the last quiz, one of them, on the sequences and series, little application problem. So let's take a look. It says, CPS instituted a Saturday school program as a consequence for referrals in an effort to reduce problem. The number of students that were assigned on Saturday school in the first 4 weeks, sorry, that should be 3 weeks, are listed here. So let's create an explicit formula. So in order for this to work, we need to find the pattern. So let's try 3,900 divided by 6,000. So that's 0.65. So let's try, make sure it's the same. So clearly, okay, this is going to be geometric, and it's times 0.65 is our common ratio. So first thing is using the Park sheet, I'm going to do the geometric explicit model. So it's first term times ratio to the n minus 1 power. Now, let's read part 2. That's all you have to do for 1. Part 2. Once the program reaches the total attendance of 18,000 students, the program will end. Assuming the pattern continues, how many full weeks? So this, guys, is your n. That means we're trying to solve for n. And since it says our context clue of total, we're using the series formula. But this is the S right here. This is your total. So when you write the equation, you're not putting S equals, it's going to be 18,000 equals, and then we're going to do the series formula for this, which I'm looking at the Park sheet, has 6,000 first minus first times my ratio to the n power, which is what we're trying to find, that's number of weeks, over 1 minus 0.65. Now at this point you could technically, we haven't solved yet, okay, we're going to start coming up in this unit next. How will we solve this equation when the letter is in the exponent? Because you can't simply divide and all that stuff, it's an exponent. So what we've been doing is you could put this 18,000 in your y1, excuse me, you could put this entire equation over here in your y2 and then find the intersection in the calculator. But like I've told you guys before, I'm not very good with this, like the whole fraction. So I'm going to show for those that might be in the same ballpark as me, let's simplify this to make it easier. So like here, 1 minus 0.65 is really, I'm just going to cross this off, that's 0.35. Okay, so that eliminates that problem. And then now I'm going to even simplify further because again, I don't like putting the fractions into the calculator. So the opposite of dividing by 0.35 is multiplying. So I'm going to take this whole side, multiply by 0.35, but what you do to one side of the equation, you have to do to the other. So times 0.35, so 18,000 times 0.35, and I get 6,300 equals, now at this point, by doing that multiplication, I don't have a fraction anymore. I still have the numerator, and I can still write that expression. Now again, at this point, if you're good with your calculator, you could put this in y1 and this in y2 and find the intersection, and it will find n for us. But I like to make it even smaller, so the opposite, I could just take this away. So then that makes 300 equals minus, remember, don't forget it's minus here, 6,000, 0.65. Now this I think is one of the easiest ones to really find at this point, guys, because it's pretty simple to put the 300 in your y1, so make sure we can see, it's a little bright. Okay, so basically I'm going to go to my y equals, and I'm going to put 300 in my y1, and I'm going to put this expression in my y2, negative 6,000. I hope you're doing this, especially if you know you didn't do so well in that quiz. So now at this point, when I put them in, the best way to do it is hit zoom 0 and see if it'll show it onto the screen. So hit zoom 0, which is supposed to be zoom fit. Now it doesn't have to be the prettiest looking graph. So you can see at the very top of mine it comes out, and then I start to see this red line. Okay, so then let's see what happens. Let's see if they ever cross, shall we? So second, calc, which is trace, and then number 5, enter, enter, enter. Oh, I meant, let me see what it says. Trace, number 5, enter, enter, enter. Okay, now mine said no sign change. Error, no sign change. And it says calculations are not detected as sign change, so meaning it hasn't crossed yet. So if it hasn't crossed, go to your window. Let's make it bigger. So let's try 100. Let's just see, and I'm making the X, I'm going to the right. And then let's hit graph. So let's take a look. Second trace, and number 5, enter, enter, enter. Pretty sure they're not going to intersect here either. Now at this point, guys, it's starting to look, even on the graph, okay? It's starting to look really like it's never going to intersect. So maybe my numbers were off or things like that. Or, to be honest, the program will still run because it never reaches a total of 18,000 students. So that would be our answer. So never reaches 18,000 students, or at least too much, you know. So they're going to keep it running, which is rare, but maybe my numbers were just bad for the problem. But that's the idea. Okay, so again, you need to really be able to manipulate and use your calculator to find the intersection, because we have not talked about how to find x as an exponent. But starting today, we are going to start converting these into what's called log functions. So what you're going to do first is watch a couple of videos of YouTube that introduce where log functions come from. They're called logarithms, how they were created. It's a little messy at first, and then what's the purpose behind them. And then I'm going to have a video notes, guys, and then we'll do through the notes and practice some of the basics today. It's, again, no calculator for the most part. Some of it's with the calculator, but it's going to be a little bit of both. So, all right, so we're going to watch the videos first.